Okay, your job for today is to convert between decimals, fractions, and percents. I do want to let you know, I told you earlier, the percents won't be on Chapter 4's test, but we're going to just talk about it today just because it fits in well, okay? Some of the key terms that we need to know are mixed numbers, terminating decimal, and repeating decimal. Who can tell me what is a mixed number? Who knows? Mixed number, go ahead. A little bit louder. What do you mean more than the, explain a little bit more.
Like 9/7.
9/7. That's actually an improper fraction, but we can convert improper fractions into mixed numbers. Go ahead. A whole number and a fraction. So here it says a mixed number is a number that contains both a whole number that is not 0 and a fraction. Okay? Then who knows what a terminating decimal is? Marwan, we'll go with you. Terminating decimal.
Some number that has, I don't know. Infinite number of decimal places.
Okay, so here's a little easier term. Okay, a terminating decimal is a decimal. When you convert to a decimal, it ends. You guys have all seen a repeating decimal before, right? Okay, and so like if you took 1 and divided by 3 on your calculator, or you did in your textbook or in your notebooks, you'd get 0.3333333, and it'd keep going. So that means it's repeating. A terminating decimal just comes to an end. Okay, so like 4/10, 0.4 is a terminating decimal. Okay, 0.425 is a terminating decimal because it ends in the thousands place. Does that make sense to everybody? And that's going to be important for us to know, especially when we go from converting decimals to fractions and fractions to decimals, okay? We're going to include both mixed numbers and proper fractions, and we could include improper fractions as well, all right? So here's a little warm-up that I'd like everybody to try right now. Little review from what we did. Why don't we just do the odds up there, just 1 and 3. Find the greatest common factor of 15 and 24, and then the greatest common factor of 54 and 102. Okay? And then I want you to write the day of the month as the product of 2 factors. The day of the month. What's the day of the month today? Okay, so you got to write December 5th as a product of 2 factors. I'm going to show both ways for doing this. The first problem for 15 and 24, I'm going to list out all the factors and kind of do the factor rainbow piece and find the greatest common factor. So, the factors of 15. You guys can help me out. Our first, we always have to remember 1. 1 and 15 are factors. What's the other factor or factors of 3 and? Okay, and that's it, right? Okay. And then when we look at 24, we know that 1 and 24, remember that 1 every single time. Because sometime soon and very soon, your greatest common factor is going to be 1. Every number shares a common factor. And 1 is a common factor for every single number. Okay? So we have to remember to always include 1 in itself. Okay? 2 and 12. And then what else? 3 and 8. And if 2 and 3 both work, then, yep, 4 and 6. Very good. Okay? So what is the greatest common factor between those 2 numbers? Okay? We see 1, but there's 1 bigger right here with the 3. So our greatest common factor, our GCF, is 3. Now, I'm going to show prime factorization. Some of you don't use this. How many kids last night on their homework used prime factorization to find greatest common factor? Raise your hand if you did. Okay? And that's using the factor trees. Okay? And just so you know, one of the things you're going to be quizzed on just happens to be prime factorization. Okay? So I'm going to start off with 54, and I'm going to make my factor trees. And I'm going to start off, because I know 54 is even, right? I'm going to start off with 2. How many 2's will go into 54? What's half of 54? 27. Okay? And now I'm going to take out a 3 because 2 plus 7 is 9. Is that right? So I know 3 has to go into it. That's the divisibility rules, which, by the way, is also going to be part of your quiz in just a little bit. And it's 3 times 9. And then 9 just is broken down to 3 times 3. So the prime factors of 54 is 2 times 3 times 3 times 3. Those are the prime factors. So that's how we find the prime factorization. We can use factor trees. Okay? I'm going to do the exact same thing with 102. And 102 is even, except how many times will 2 go into 102? Or what's half of 102? Yeah, 51. Is 51 prime?
Yeah. No.
Someone tell me why 51 is not prime. Why is 51 not prime? Go ahead. Why? How do you know 3 goes into it? Sure, if we add up the digits, 5 plus 1, we get 6. And because 3 goes into 6, we know that 3 must go into 51. Does anybody know how many times 3 goes into 51? Yeah, 17 times. Okay, and we can double check that. We'll use the distributive property. 3 times 10 is 30, and then we're going to add that to 3 and 21, or 3 times 7, which is 21. So 30 plus 21 gives us a grand total of 51. Okay, 17. Can we break it down? It is a prime number, isn't it? 2 won't go into it. 1 plus 7 is 8. 3 won't go into it. We know 4 doesn't go into it because 4 goes into 16. Definitely won't go into 5. 2 and 3 don't work, so we know that 6 won't work. Okay, we're done right there. Now, to find the greatest common factor by using prime factorization, we find all the common prime numbers that they have. Okay? So what do they have in common? 2 here, 2 here, 3 here, and a 3 here. So the greatest common factor would be the 2's that they share in common times the 3 that they share in common, and that gives us a grand total of 6. We have to multiply those common prime numbers that they share. Okay? Now, does 6 go into 54? Does 6 go into 54? It better. If it's one of our greatest common factors, it better go in there. And 6 times 9 is 54. Does 6 go into 102? It better if it's our greatest common factor. 6 goes into 102. Let's see, that goes in there 17 times. 17 times. How many kids got number 3 right? How many kids put 3 down as their greatest common factor? How many did anybody put 2? Okay. All right. So if you're going to write the day of the month down as a product of 2 factors, today is the 5th. Guess what? The 5 is a prime number. So what's the only way to get to the 5th? 1 and 5. So if we're going to do this, we would say 1 times 5 is 5. There it is. Okay? All right. So here's the main thing that we need to be able to do today. And I'm going to just move this. Well, maybe this doesn't move. Okay. Decimals and fractions. We can write any decimal as a fraction, and we can write any fraction as a decimal. In fact, they need to be equal. They are the same. Okay? One thing that you can do is use a place value chart. Or you can just say the number. When you say the decimal number, you can easily convert it to a fraction. So if we wanted to say, for instance, 47 hundredths. 47 in this place value looks like this, 0.47, that's 4 tenths and 7 100ths. The actual fraction is 47 hundredths. They have the exact same value. We know that 47 hundredths in comparison to 1, it's pretty close to 1/2, isn't it? Everybody agree? Is this fraction pretty darn close to 1/2? Yeah, they're the exact same thing. Okay? Same thing with a mixed number. If we have 8 3/10, not a problem. Just write down exactly what you just said. This is why we don't want to call this 8.3. If we call it the right way, 8 3/10, then we know that it's going to equal exactly 8 3/10. Now, I will tell you from time to time, you are going to have to simplify your fractions. When you convert your decimals to fractions, there are times where you're going to have to simplify. Okay? Any questions on that? That's going to be one thing. This shouldn't be new to you. You guys should have seen this last year. Is that correct? Okay. Now, the other piece that we have to do is be able to go from fractions to decimals. And this is going to bring back some bad memories for some of you because it involves division. So if we're going to write 1/4, first of all, I think it's really important that everybody in here should memorize what decimal number is 1/2, what decimal number is 1/4, what decimal number is 3/4, what decimal number is 1/3, what decimal number is 2/3. We should have all those memorized for sure. Does anybody know what 1/4? 1/4 is equal to what decimal number? Go ahead. 0.25. And if you have 1/4, how much is 1/4 worth? Yeah, and if we want to make that a fraction, 1/4 compared to a full dollar, you have 1/4 out of the total number of 4 quarters for $1, right? There's 25 cents right there. Okay? So here's what we do. We just look at the fraction and we do what the problem says. 1 divided by 4. That's all we need to do. When you write a fraction, you're actually writing a division problem. That's all it is. 1 divided by 4. So every fraction is a division problem, and every division problem can be written as a fraction. They are one and the same. So I'm going to just convert this 1/4 into this type of division problem right here. The top number goes inside the house. The bottom number goes outside. And if you do the lucky 7 method or the partial quotients, that's fine. It's still the same thing. Okay? So I'm going to do, I'll do this the traditional way for this one right here. I'm going to put in my decimal point because I know that 4 won't go into 1 by itself. Is that right? So I know that I'm going to have 0 whole numbers. I subtract this 0, and now I have 1. I'm going to add my 0 in. It doesn't change the value of that number. And how many 4s will go into 10? Okay? And it's actually 2, right? Now, what this question actually says is how many 4s will go into 1, and we're saying that it's 2/10. 2/10 of a 4 will go into 1. 2/10 times 4 actually gives us 8/10. Now, for those of you that do this method, you probably don't add the decimals in here, but that's truly what this is saying. Okay? When we do our subtraction, we have 2 left over. I can add another 0, bring it down, and how many 4s will go into 20? 5. Now I want you, this 5 is actually in the hundredths spot. 5 hundredths times 4 does equal 0.20. And we have 0 left over. So we get our 0.25 or 25 hundredths. And if we tried to simplify 25 hundredths down to 1/4, it works out perfectly. Do we have any questions on that? So today, yeah, Marwan. I am. We're at 15 minutes right now. I am. And I'll make sure that it actually works out. So, and then once I do that, you might not be, if you look tonight, you're going to have to try and find it. Tomorrow, I'll show you where the videos are going to be located. But if you look tonight, if everything works out, I'll put it right on my webpage. Not today. I'm going to put it on my YouTube. I'm going to actually bring it to my YouTube, and then I'll copy the URL, and then you can just click on that from my webpage, and you'll be able to watch exactly what we're doing. But I'll show you that tomorrow. We're not going to take time to do that today. Okay? No, let's keep moving on. Okay. So what I'd like you to do is try and convert a few. Okay? Let's try a few. Can you convert 3/4? Can you convert, I'll make this a little bit bigger. Can you convert 3/4, 2 1/5, and 7/8? Can you convert them to decimals? And then if you can do that, can you convert these decimals down here into fractions? I'm going to give you a few minutes to do that right now. Okay, we're going to continue here. 3/4. 3/4. We should all know 3/4. This is one that I told you that we need to know. 3/4 is what? 0.75. So 3/4, when we divide 3 by 4, we get 0.75. Now, I want to just tell you about percents real quick. Percents mean per 100. 1 all by itself, 1 is 100%. Okay? This is obviously less than 100%. If you scored 3 out of 4, you're not going to get 100%. Right? If you scored 4 out of 4, you would be at 100%. And 4 divided by 4 is exactly 1. Okay? This number is actually equal to 75 out of 100. And percent just means out of 100. This is exactly 75%. Okay? 2 1/5. Now I'm going to show you a quick, here's an easy one. Because our place values in decimals go in tenths, hundredths, thousandths, then 10,000ths. If we find a common denominator, okay, and this 1/5 right here, I can easily make into tenths. 1/5 is equal to how many tenths? Who said 2? Explain why. It is 2. Yeah, because whatever you do to the bottom, you have to do to the top. And that's how we make equivalent fractions. And guess what? That's what we're going to be doing soon and very soon. Writing equivalent fractions. And as long as we understand that it's only multiplicative, that means that we can only multiply or divide. We can't add or subtract. Okay? So now that I have it into tenths, I can say 2 and 2/10. Guess what that looks like as a decimal? 2 and 2/10. Now, if I said that 4 out of 4 is 1, and that equals 100%, anybody want to try and guess what percent this is equal to? If 1 is 100%, this is going to be bigger than 100%. Thank you. Say it again. 220%. This 2 represents the 200, and this 2 right here is actually 20 hundredths. We can put in a 0 here, not change the value, and that means 20 out of 100. It's 220%. 7/8 is probably the toughest one. Who has 7/8? What'd you get?
I got the percent or the decimal.
Decimal. 0.875, and it is correct. Okay? And you did 7 divided by 8, is that right, to find it?
No, I remember last year.
You remembered from last year. I think that's about right. We could pull out anybody have a calculator on them? Can you quickly do 7 divided by 8? Does anybody know what percent this would be? If we rounded it up to the nearest percent, it would be 88%. Anybody have a guess? Go ahead. No, it's not 800. Look at here. This is 220% right here. We need to have at least 2. It's going to be less than 100%. I'll give you that hint. Yeah.
87.5%.
Did everybody hear that? 87.5%. That means it's 87 and 1/2%. We okay with that? Okay. Now keep in mind the percent piece I'm just showing to you right now. It's part of our standards. You're not going to be tested on it right now. And I know I need to hurry up, so I'm going to go real quickly on the next part. 0.4. Who can tell me what percent it is?
40%.
What did you say?
40%.
It is 40%. It's not 4, because right here, this 0.3 is 3%. This is 40. Okay? 4/10 is 4/10. Okay, 2.3. 2 3/10. It's 230%. Good job. What fraction is it? 2 3/10. Okay? 2 3/10. All right? 842.5%. You're right. Good job. What fraction is it then, Robert? 425 over 1,000. Okay? Remember, look right here, everybody. Tenths, hundredths, thousandths. So that would be 425 thousandths. And there it is. Whoop, I need to add another 0. 425 thousandths. Okay? Then our last one. 300ths. It's equal to 3%. That means it's 3 out of 100. That's what a percent is. A number out of 100. 3/100ths. Okay? So there's your practice for today. I need everybody to pull out their notebooks or their planners right now. Here's your actual homework. It's up on the board.